A. And of course, I want to get rid of negative 2bc, so I'm going to divide it by negative 2bc. And that gets rid of negative 2bc. And there it is right there. At this stage, what happens to a lot of teachers or the books, they factor out a negative here, and they cross-cancel with the negative, so it becomes 2bc in the denominator. Numerator becomes b squared plus c squared minus a squared, but we're not going to be doing that. We'll just keep it like this. Just plug it in to your calculator. A squared 34 squared minus b squared 20 squared minus c squared 18. And then I'm going to divide that. You have to put, so what I did here to make it easier on you guys, I just said 34 squared minus 20 squared minus 18 squared, and then I put the answer and then divide it by, you have to put parentheses around the negative 2bc, okay? Or else you'll get a wrong answer because it's not dividing by that factor. Minus 2, negative 2 times b, which is 20, times c, which is 18. And I end up with negative 0.6 right here. Is that right so far? Did I use angle A? Yeah. And then I take the answer, inverse cosine of the answer. To solve for angle A right here, I have to get rid of this cosine. I cannot divide by the cosine. I must divide by, not divide by, take the cosine inverse to get rid of that cosine. So this turned out to be approximately negative 0.6. So the cosine of the angle A is approximately negative 0.6. The angle A is equal to cosine inverse of negative 0.6. And I did that for you. Angle A is approximately 127 degrees. Okay. So that angle A is 127 degrees. From here, you can use the law of sines to get rid of, to find the angle B, and to find angle C, don't have to use the law of sines anymore because we know that they have to add up to 180 degrees. I'll leave that as an exercise to you guys. It should have been covered in the law of sines, LOS for sure. Quick note, notice that this angle is 127 degrees. These must be the smallest angles. That big angle, opposite is the big side. So the quick check says that the rule of thumb works pretty good. Okay. The rule of thumb is opposite biggest side, opposite biggest angle. So that's the SSS case where you don't have any of the angles. Let's try one last example here. And this one's a little bit difficult because this example, number 4, they use what's it called? The bearing method. Remember that the bearing north is equal to 0 degrees, and going this way is positive, and going to the left is negative. So going to the right is positive, going to the left is negative. If I say something like this, 120 degrees, it's going to start off at north here, and it's going to go clockwise to 120 degrees. Sometimes another way to write this is, if I draw it out right there, that's going to be 90 degrees. That angle is 30 degrees. So we could say east, 30 degrees south. So this is your starting position, right over here. You're going eastbound, and you're going 30 degrees on the south side. So you can do it this way on bearing, or this way if you're going true north. Some of the things about bearing is also, as I reminded you earlier, is that it works very well for land and sea only. So if you're in a balloon, you're flying in a plane, helicopter, just bought one for my son, his birthday. Going to try to work it out, but it could be on boat too as well. So anytime you're on air, see, you're gonna be using bearing. Okay. So let's look at example number 4 and work it out. A plane is flying at an airspeed of 185 miles per hour, heading 120 degrees at 120 degrees. And the wind is going constant 32 miles per hour at 165 degrees clockwise from due north. Find the true course and the ground speed of the plane. So we start off again here, going north, and I gave you this hint right here. It's going 120 degrees north. So this is the direction of the plane. Remember, if it has direction and magnitude, it's a vector. I'm going to exaggerate it a little bit, and I'm going to be drawing here 120 degrees. And then starting at this point right over here, remember that vectors are, you can add vectors because from tail to head, and then we can also add the wind speed too. It's going 32 miles per hour. Here's due north again. I should have done this in black. So let's do this in black this time. Sorry about that. That's north. And it's going 32 miles per hour, 165 degrees. So it's 120 is right here, so 165 should be this way. And I exaggerated it as well. It should have been a little bit smaller. And it's 32 right here, 165 degrees. I'll draw this in black, and 185 here. And this should have been 165 degrees. We know certain things. I'm going to do it just a little bit differently than the book does it, but we should get the same results. If a plane is going this way, 185 miles per hour, and the wind is pulling you this way down at 32 miles per hour, the net course of the plane's speed is going to look something like this. And I'm going to use green. And there it is right there. So the green is your final speed of your plane. We know certain things. This is 120 degrees. These are parallel because they're all pointing north. And this is 120, so this must be the complementary of that. It should be 60 degrees. So we know that is 60 degrees. The way the book does it, they draw a line and find that angle, and then it should be, I think they use the corresponding angles. I'm going to use the same side interior angles, and they're supplementary. So from here, parallel line cut by transversal, same side interior, 120, 60 degrees. Since this is 60 and this is 165, I'm going to just use our calculator. 360 minus 60 minus 165, and you end up with 135 degrees. 135 degrees right there. So that's 135. You have your side, and that side you should be able to find this length using the SAS situation or the law of cosine. Okay. I'm not going to actually do this one for you. You can finish it up. It's not that difficult. The setup is the hard part. Getting all the information down, drawing out the figure as big as possible, and working out how the airplane's moving, basically. Good luck to you on this. Oh, by the way, once you find this out, you can figure out what this angle is right over here, that small angle. And the book says it's approximately 6 degrees, so the true course is 126 using the law of sines. Good luck to you guys, and happy hunting. Study hard. Bye.